हेलो एवरीवन, हाउ आर यू? कैसे हैं आप लोग? राइट, गौरव प्रजापत, जय माता दी दोस्त. राइट नाउ केयूर पटेल, गुड इवनिंग. गौरव, पीयूष, राइट, श्रीअप, जया, कंगना, सॉरी कन्नागा, अनुज, पीयूष. आप बताओ सर. पीयूष बिल्कुल बढ़िया दोस्त, मैं एकदम बढ़िया हूं. राइट राइट. अखिल तेज, धीरज सेन, अनुपम, वेरी गुड. राइट नाउ वी हैव डिस्कसिंग, हमने लास्ट क्लास के अंदर हमने जो डिस्कशन किया, वी आर रिकॉलिंग अगेन. दैट इज द लास्ट क्लास. अनुपमा, युगंधर, युगंधरा, सुनील, पीयूष. राइट नाउ इन द लास्ट क्लास we have discussed about the NOT gate. NOT gate के बारे में हमने डिस्कशन किया था. In the NOT gate we have discussed there is the only single NOT gate, right? Sanawaz, good evening dear. Right, there is the only single one NOT gate. In the one NOT gate, if the 0 is given, then the output will be 1. If the 1 is given, then the output will be 0, and there will be the some time. That time is called the propagation delay, right? And when two NOT gates are connected in the cascaded form, when the two NOT gates are connected in the cascaded form, then we can say that that circuit is work as what? That circuit is works as a buffer. वो buffer था मेरे दोस्तों. That will be the buffer, right? नंदा, right? Okay. Now that circuit is called what? Buffer. वो buffer था दोस्त. अब होता क्या है in the buffer? There will be the two application of the buffer, right? There will be the two application of the buffer. The first one is what? The first application of the buffer is the propagation delay, to provide the propagation delay. And the second, yes, Utkarsh Patel. Sir, FFT, definitely Utkarsh will discuss the FFT in the revision class of the GATE 2020, that is 5:45. 5:45 के टाइम पे विल डिस्कस द एफएफटी, राइट? सो डोंट वरी, सारी चीजों का आपको सोल्यूशन दिया जाएगा, टेंशन लेने की जरूरत नहीं है. बस जुड़े रहिए, लाइक करते रहिए, शेयर करते रहिए. राइट नाउ सो टू नोट गेट के बारे में मैंने बता दिया. एंड द सेकंड वन इज व्हाट? द सेकंड वन इज द इंपेडेंस मैचिंग. इन द इंपेडेंस मैचिंग व्हाट हैपेंड? देयर विल बी द टू सर्किट 1, circuit 2, circuit 1, circuit 2. Circuit 1 having the output impedance high, circuit 2 having the input impedance low. So there will be the mismatch between the impedance. So if we'll connect that circuit 1 and circuit 2, the current will flows always from high impedance to low impedance. So current कहाँ move करेगा? That is from 1 to 2 or 2 to 1. So definitely that is from 1 to 2, and that current is known as high current or impulsive current, and there is the possibility to what? To burn the element of circuit 2. कल की क्लास में डिस्कशन किया था, right? So if we'll discuss about what? So we have to place what? Buffer between these two circuit. In the buffer the input impedance is high, output impedance is low, so there will be the matched. Problem is dissolved. Right now my dear friend साहू जी, hello dear, कैसे हैं? Right, मनीषा रानी, hello sir जी, hello. Right now we are moving on the next. Right, उसके बाद हमने क्या किया? दो नोट गेट लिए. वी हैव टेकन द टू नोट गेट इन द फीडबैक, राइट? राइट, एंड द नेम ऑफ द सर्किट इज व्हाट? इसके अंदर 0 दिया तो 0 दिख रहा था, 1 दिया तो 1 दिख रहा था, A दिया तो A हमेशा स्टोर हो रहा था. द नेम ऑफ दैट सर्किट इज व्हाट? देयर विल द थ्री नेम. द फर्स्ट वन इज व्हाट? द फर्स्ट वन इज कॉल्ड द बेसिक मेमोरी एलिमेंट, माय डियर फ्रेंड. दैट इज द बेसिक मेमोरी एलिमेंट. एंड द सेकंड वन इज कॉल्ड व्हाट? द सेकंड वन इज कॉल्ड, राइट, नवीन, कोई दिक्कत नहीं दोस्त, लेट नहीं है, बिल्कुल सही समय पे अभी शुरू ही हुआ है. आई एम जस्ट गिविंग द ब्रीफ आइडिया अबाउट द यस्टरडे क्लास, राइट? सो दो नोट गेट लगे हुए थे लूप में, और मैंने लिखा कि whenever the even number of node get connected in the loop, the circuit will be known as what? The circuit will be known as what? Basic memory element. The second one is the bistable multivibrator, and third one is what? The DC generator, right? Because it will provide the only constant value. Now for the next one, difference between the propagation delay and the transition time. The transition time is a different thing, Sanawaz, and the propagation delay is a different thing. We'll discuss the transition time in the logic family, right? In the logic family we'll discuss this thing right now. Right, Shubh Lakshmi, English sir, definitely Shubh Lakshmi, the technical concept will be delivered only in the English, so don't worry about that. Whenever I am you know what, speaking in Hindi, it means that is not a technical word, that is just a general thing, right? That is not a technical, that is the general thing. Right now we are moving on the next. अब अगले में क्या बात कर रहा हूँ? For 3 node gate connected in loop, then when the 3 node gate connected in loop, the circuit will be known as what? The circuit will be known as, there will be the 5 name of the circuit. The first name is what? The unstable multivibrator. The second name is what? The rectangular or square wave generator. Third one is what? The clock generator. And the fourth one is what? The fourth one is what? The fourth one is, my dear friend, for the fourth one is the ring oscillator. right? Ring oscillator, or sorry, free running circuit, and the fifth one is the ring oscillator. So 5 हमने नाम बताए थे, and the time period of the circuit will be nothing, it is just a 2n topid, 2n topid, and is nothing, it is just a number of node gate in loop, and we can use that formula only when the odd number of node gate connected in loop. जब भी कभी odd number of node gate connected loop में होगा तभी उसका वो नाम था, right? Now we are moving on the next. हम next topic पे चलते हैं, right? Yes, free running circuit, Piyush, yes, correct. Right now we are moving on the next. उसके बाद we have done discussed the few, or f is nothing, it is just a 1/2 and topid d, and we have discussed a few question, right? Now in this session we are discussing the node gate. हम node gate को zoom करके देखेंगे, right? We'll zoom the node gate. What is the basically the circuit of the node gate, right? Site PDF for the IS eyesight, how should be. Okay, John will discuss that thing later, right? Now that is a brief idea about me. My name is Chandan Jha, right? Cracked the ISRO exam. I'm taking communication network. Apart from the teaching, I am also taking the motivational session. I have already conducted the more than 200 motivational session in various engineering colleges, including NITs and some IITs. And that is my expert subject, that is called digital electronics, control system, signal and system, communication and microprocessor. Now my dear friend, मैंने आपको कल we have discussed a few question, right? कल की क्लास में हमने कुछ क्वेश्चन डिस्कशन किए थे. That question will be what? The first question of this is the sketch the waveform of Y. So have you solved that question? Have you solved that question? Yes. It is also what? It is also a stable multi-vibrator. It is also, my dear friend, it is a stable multi-vibrator, right? Because we have to look in the consideration the number of node get connected in loop, right? So the Y is nothing. If there is a X, then Y is nothing, it is just a X bar or complement of X. Bar के नाम पर भावुक नहीं होना, right? That is the complement of X. Now we can say that X is nothing, it is just like this, right? If I'm saying X, then X is nothing, it is just like this, right? It is the X, right? Now if you want to find form Y, then Y will be nothing, it is just a complement. So I'm writing it a Y, that is a complement, so I'm writing like this. It is the Y, it is the Y. But obvious that Y should be present after the some delay of this what? That is the topid d. So at this particular time we can say that this is nothing, it is just a 3 topid d. We have already discussed. This is nothing, it is just a 3 topid d. Everything is the 3 topid d, my dear friend. सब कुछ 3 topid d हमको पता है ये चीज, right? Now if we want to find out the Y, so this value is also just a complemented value, but it will present after the some time. So we have to shift the signal by topid d. If you will shift that signal by topid d, then we can say that the signal will be looking like this. We have to shift the signal. So the positive part and negative part both will be shifted to the right hand side with the topid d. So we can say that the signal will be looking like this. It is looking like this, right? It is nothing, it is just a topid d, right? So it is 3 topid d again, it is 3 topid d again, it is 3 topid d again, but that signal will present what? After the 1 topid d. So it is also the frequency of that signal is also the same as what? The same as X. And if you want to find out the frequency of Y, then that will be nothing, it is just a 1/2 n topid d, that is called 6 topid d. The frequency is same as what? The 6 topid d, right? That is a very easy, my dear friend, that is a very easy thing, right? Now we are moving on the next. Right, sir, amplitude will be constant. Yes, that amplitude should be constant, right? I'm taking as a what? The ideal condition. That's why that is the constant, right? Now we are moving on the next, right? ये question आपने solve किया ही होगा. Now we have discussed that question. कल ये भी question आपको as a homework दिया गया था, right? In this question, for the circuit given below, X and Y condition will be, and this is the switch actually. That switch is connected in this circuit only when to provide the one to the circuit, right? So if one is applied, then the switch will be closed, open, right? Then switch will be open. So if there will be the 1, there will be the 0, there will be 1, there will be 0, there will be 1, again there will be 0, there will be 1, there will be 0, there will be 1, there will be 0, and so on. Infinite time that loop will goes on, and every time the value will be what? 0, 1, 0, 1, 0, 1, 0, 1, and the change in the value 0 to 1, 1 to 0 is called the toggle condition, my dear friend. Mere dost babu, that condition is called what? Toggle condition. So we can say that in the not only in the x and y, everywhere the value will be always changed. Then the every place the circuit will be works as a yes, Nanda correct, Jaya correct, Piyush correct, Karthik correct. That is the C, x and y both toggle, not only x, y, at the every point is the basically the toggle condition, right? Every point is the basically, my dear friend, that is the toggle condition, right? Now we are moving on the next. Now we are moving the circuit diagram of the what? NOT gate. Circuit diagram of the NOT gate. So before going to the circuit diagram in the NOT gate, sir, please again explain, Dheeraj Sen. For which topic, dear? For this? Okay, Dheeraj. If there is the 1, then obvious by the NOT gate there will be the 0, 1, 0, 1. Again it will become 0, 1, 0, 1, 0, 1. Then again it will be the 0. Again it will be 1, 0, 1, 0, 1, 0, 1, 0. So every point will be toggled. But if the every point is toggle, then it is called what? X and Y both are worked in the what? As a toggle condition. Right? Dheeraj, are you getting my point? Right now, we are moving on the next. That is the circuit diagram. It is the circuit diagram of the inverter. NOT gate ka dost, ye mera circuit diagram hai. Now for this particular question, just remember in the digital, we are using only two conditions, right? For the digital only we are using the two conditions. Which condition? What is the role of the switch? Shanavas, the role of the switch in everywhere. Even in the power electronics, if you are the electrical branch, then in the power electronics you require the switch. If you want to connect the battery, then sometimes it required to disconnect that battery also and some other source also. So there is always requirement of the switch. Right now we are moving on the next. ये नोट गेट है मेरे दोस्त. अब कैसे काम कर रहा है नोट गेट के लिए? Just remember one thing for the particular node gate, right? We can use the transistor only in the two mode of operation, right? Either the transistor will works on the cutoff or the transistor will works on the what? On the saturation. अब कब हम cutoff बोलेंगे, कब saturation बोलेंगे, that is the important thing, right? So I am writing before this, I am writing in the transistor, this terminal is called, right, base. This is called collector, this is called emitter. So I am writing this terminal as a input. So if in the input 0 is applied, then transistor will be always off. Off means what? Off means cutoff. Cutoff means what? Cutoff means open circuit. Koi bole open circuit kya hai? Just remove the transistor, that will be the open circuit. Now when at the input of the transistor in the digital we are providing only either 1 or 0, either 1 0, इसके अलावा तो कोई condition बन ही नहीं सकती. So at the input, if it is the 1, so in the input, my dear friend, if it is a 1, then the transistor works on what? Transistor works on the on condition. On means what? On means saturation. Saturation means what? Cutoff or saturation means what? Open circuit or short circuit? Open circuit, short circuit. थोड़ा जल्दी से बताइएगा. Sir, saturation means obvious. That is the short circuit. So that is the short circuit. So my dear friend, if you want to find out what? If input is 0, then transistor will be off. If input is 1, the transistor will be in the saturation region. Now I am providing, that is the basically NOT gate. अगर इस NOT gate को आप zoom करेंगे, if you zoom that NOT gate, the circuit will be looking like this, right? Looking like this. Yes, Manisha, correct. Now if we will providing the 0 in the input, the transistor will be on or off. Of course, the transistor will be off. If the transistor will be off, just remove the transistor. If you remove the transistor, then the output will be nothing, my dear friend. The output will be always the VCC. And VCC is what? VCC is the high voltage. So when 0 is applied to the input, the output will be VCC. And VCC means what? 1. VCC means what? 1. Now, sir, what if the equal to 0.5 VCC? Nanda, just think once. If the voltage is not either in the 1 or 0, high voltage or low voltage, then that topic will be converted into, or the topic goes into analog electronics, right? That then in the analog electronics you will deal in very much of the detail related to the transistor. But in the digital electronics we are dealing only two conditions: either the transistor will be on or off. right? So my dear friend, now if we'll apply what, बाबू अगर हमने यहां पर अप्लाई कर दिया है क्या, if we are applying one, if we are applying a 1, then the transistor will be cut off or saturation. Sir, of course the transistor will be what, in the saturation. Saturation means open circuit or short circuit, open circuit or short circuit. Of course that will be the short circuit. So it will directly, output is directly connected to what, the output is directly connected to ground. That's why the output will be what, the output will be 0. That's why the output will be 0. 0 दिया 1 मिला, 0 दिया 1 मिला, 1 दिया 0 मिला. It is nothing, it is just a what, it is a transistor, it is a it is an inverter, my dear friend. So it is the circuit diagram of what, it is the circuit diagram of that inverter. ये एक NOT gate का circuit diagram है, right? Now we are moving on the next. So in the NOT gate we have discussed about the stable simple inverter, after that buffer, after that bistable multivibrator, after that astable multivibrator, and after that the circuit diagram of what, the inverter. These things you should remember. सर अगर रजिस्टर अमीटर ब्रांच में कनेक्ट करे तो बिल्कुल दोस्त करेंगे, आने वाले टाइम में करेंगे, विल फॉर्म द एंड गेट बाय दिस ट्रांजिस्टर आल्सो, राइट? सो हम कनेक्ट करेंगे, कोई दिक्कत नहीं, राइट? That is called RE. RE is generally used for the feedback, right? Now we are moving on the next. Anas Khan is asking about the PDF. Which PDF you want, my dear friend? I'm not getting you actually. Right now, that is the 7404. That is the standard IC for what? NOT gate. So NOT gate का IC number का याद रखिएगा कितनी बार? That is not in the PSU, right? Some not in the gate or ESE. Sometimes they are not using the word NOT gate. They are using the word, the 7404 IC is used. Or you should remember always one thing, the 7404 is nothing, it is just a what, NOT gate. And in this circuit IC, that is not a single NOT gate. There will be the 6 NOT gate, 1, 2, 3, 4, 5, 6. And yes, always remember the NOT gate having what? The NOT gate having the only one input and one output, right? Sir, PPT, PDF जो आप पढ़ा रहे हो, अंश आप इस पीपीटी का इंतजार मत करिए, यू जस्ट नोट डाउन एवरीथिंग इन द कॉपी. लास्ट क्लास में मैंने आपको बोला था क्योंकि हर एक चीज इन द फिंगर ट्रिप्स, राइट, इन द फिंगर ट्रिप्स. सो नो रिक्वायरमेंट ऑफ दैट लास्ट क्लास नोट्स, राइट? पर अब से आपको क्या करना है, एक नोट्स खरीदिए, कॉपी खरीदिए, उस कॉपी के ऊपर लिखने की कोशिश करिए, राइट? नाउ सर शुड वी रिमेंबर द आईसी नंबर? यस, मैं इतनी बार ये यूज करूंगा वैसे ही आपको रटा जाएगा, 7404 7404 7404. सो जस्ट रिमेंबर दिस वन, इट इज नथिंग, इट इज जस्ट आईसी, बट दैट इज नॉट रिक्वायर्ड फॉर द गेट. In the gate they will always mention the inverter, they are not mentioning the what IC number, but in the sum of the local exam we can say that state level exam they are directly using the what IC number. So you should remember 7404 related to NOT gate, and there will be the 6 NOT gate, single input single output, right? Now we are moving on the next. ये तो दोस्त पूरी कहानी थी किसकी? NOT gate की. That is the story related to NOT gate, that is inverter. Now we are moving on the next topic, that is called AND gate. Right, we are moving on the next topic, my dear friend. That is nothing, it is just a AND gate. We are discussing the AND gate here. Now that is the symbol, is the AND gate. Actually everything is basically designed by the set theory. In the set theory there will be two things. One is the union and another one is the intersection. One is the union and another one is what? Another one is the intersection, right? So intersection is called what? The intersection is called ANDing and union is called ORing. So just remember one thing, right? If you want to find out the AND gate, so I'm writing the logic of the AND. Just remember the ANDing operation, right? For the ANDing operation, 0.00 0.1 0 1.0 0 1.1 1 1.a 1.a bar a dot a dot 0 0 a dot a bar 0. So just remember these things, that is a very very important. The dot is nothing, it is just a intersection, that is the common part. ये भी 0 ये भी 0, दोनों ही कंगाल, दोनों में कॉमन क्या है? उनकी कंगालियत 0, right? 0 dot, ये कंगाल ये 1 0, right? So everything you should remember, and these are the important thing. A dot a bar, एक A है एक A नहीं है, दोनों में कॉमन क्या है? सर कुछ भी कॉमन नहीं है, right? That is the 0, right? Now for the ORing, just remember one thing, my dear friend. 0 ORing 0 0, 0 ORing 1 1, 1 ORing 0, 1, 1 ORing 1, that is again 1, 1 ORing A, 1 है साक्षात भगवान, जो भी जाएगा सब समा जाएगा, 1, right? A ORing 0, A ORing A, A ORing A bar, A ORing A bar, that is 1, right? That is related to what? That is related to union, right? So these points you should remember always, right? Honey Singh 1 plus 1 equal to 2, very good, that is in the digital. One thing more, you should remember one thing more. What? Sir, that is not a plus. If you are using the plus word, that is in the wrong. You are adding. We are not adding, that is the logical operation. In the logic, if I am writing 1 ORing 0 or 0 ORing 0, then the answer will be 0. But if I am using 0 plus 0, 0 plus 0, then answer is not 0. The answer will be 0, 0. Because in the addition, there will be the two output. One is what? One is for sum, another one is for what? Carry. So, if you are using 0 plus 0, it means that your answer should be what? 0, 0. Sum and carry. And if you are using 0 ORing 0, then the answer will be only 0. So, just remember this one, right? Now, we are moving on the next, that is called what? AND gate, right? Now for the truth table of the AND gate, 0, sir, 0 or, right, that is the AND gate, A dot B, 0.0, 0, 0 and 1, sir, 0, 1 and 0, 0, 1 and 1, of course, it is a 1. So, my dear friend, just remember one thing, in the lots of PSUs, there were the one question, एक question पूछ लेता है बहुत सारे PSU के अंदर, there is the simple question, what is AND gate? Right? Generally, they are asking what is AND gate, right? If you are making the symbol like this, it is AND gate, then my dear friend, it is not an AND gate. AND is not a basically gate. ये सब कोई gate नहीं है. AND is not a basically gate. AND is a basically logic. And what is the logic of AND gate? Whenever the any input is low, the output will be always low, irrespective of the previous state or irrespective of the other terminal. So just remember one thing, in the one line you can define the AND gate. AND is nothing, it is just a logic. And what is the logic of AND gate? So logic of AND gate is whenever the any input is low, the output should be always low, irrespective of the other terminal is called what? It's called AND gate, right? Getting 60 to 65 in ISRO, Bhavya, okay, getting Bhavya, sorry, not Bhavya, that is Bhanay Shankar. Bhanay, that is not a basically safe score, I think. Or do not, just wait, we'll discuss that topic later. I am covering the digital electronics, right? Prima mole, we are covering the digital electronics. If the one input is not defined, still output is 0, yes. If the input is any one terminal, the output is 0. In the one terminal, the input is 0. The output will be always low, irrespective of the other terminal. दूसरे terminal को देखना ही नहीं मेरे दोस्त. ये समझ लो exam का pattern, the exam pattern. एक subject में fail, बीटेक की बात नहीं हो रही. fail मतलब होता ही नहीं बीटेक में तो. कॉलेज की स्कूल की बात हो रही है, स्कूल की बात हो रही है, स्कूल की बात हो रही है. एक subject में fail तो पूरा fail, एक subject में fail पूरा fail. That is what? It is a AND gate. It is a AND gate, right? Now we are moving on the next, my dear friend. That is the truth table we have already discussed. If the any input is low, the output should be always low. We know that. Whenever the any input is low, the output will be always low. It is called what? AND gate. So you should remember about the definition of what? Definition of AND gate. And once again, just hit the like button, my dear friend. Hit the like button, right? Right now, we are moving on the next. Right? After the AND gate, that is the basically the what? That is the basically truth table of the AND gate we should remember, right? Now we are moving on the next. Enabled and disabled condition. Now enabled and disabled condition. Just remember one thing, my dear friend. If it is the AND gate, I am connecting a A to this terminal, and this terminal I have kept openly, right? This terminal is free. That free terminal is called, there will be the three name of the free terminal. The first one is called floating terminal. Floating terminal. Second name is what? Control input. And the third one, generally we can also say that as a stop, right? So इस खाली छूटे हुए टर्मिनल को जो लटका हुआ है उसका नाम क्या है? That will be the three name. What? The floating terminal. You can call as a floating terminal. Second one, the control input, and the third one, nothing, my dear friend, that is called stop, right? Now So what is the name of this terminal? Sir, floating terminal, control input, stop. Now I am connecting 0 at the floating terminal, stop or control input. And if we'll apply 0 here, then again the output will be 0. And now if you'll apply 1, then again the output will be what? 0. Because it is the AND gate. In the end, whenever any input is low, the output will be always low irrespective of the terminal. So if you are changing the input, with the changing in the input, the output does not vary, does not change. That's why this AND gate is also called control 0 disabled. It is also called control 0 disabled, right? It is also called control 0 disabled, right? Right now we can move that, right? That is control 0 disabled, right? Now just remember one thing, my dear friend, for the control 0 disabled this thing. So जमाने गए जब आता था, जब ये बोला जाता था कि एंड गेट, आजकल क्वेश्चन थोड़े खतरनाक होने लगे। आजकल वो सीधा बोलेगा क्या सर, वो बोलेगा कि एंड कंट्रोल 0 डिसेबल्ड, कंट्रोल 0 डिसेबल्ड लॉजिक इज यूज्ड, यू हैव टू क्लियर इन योर माइंड, दे आर आस्किंग अबाउट व्हाट, दे आर आस्किंग अबाउट द एंड गेट। स्टॉप इज नथिंग माय डियर फ्रेंड, अ कंट्रोलिंग टर्मिनल, हम बाद में डिस्कशन करेंगे स्टॉप को, बट एट दिस टाइम वी कैन से दैट द कंट्रोलिंग टर्मिनल इटसेल्फ नोन एज व्हाट, स्टॉप, राइट? नाउ we are moving on the next, right? Now we are moving on the next. We are providing what? At this terminal is again also known as what? Floating terminal, stop or control input. We are connecting the one in this terminal. We are connecting the one in this terminal, and we are kept A at this point. Now if we are providing the 0, the output will be 0. Now if we will provide 1, the 1 ending 1, that is what? 1. So we are changing the input. We are changing the input. And according to changing the input, the output will also change. The circuit is enabled or disabled. So of course the circuit is enabled. So the AND gate is also called control 1 disabled. So AND gate is also called, sorry, not disabled, enabled. So it is also called control 1 enabled. It is also called, my dear friend, control 1 enabled, right? Now Sirap sir, very good animation sir, very helpful. Oh Sirap, thank you dear. Right now it is not about, right, at this time, yes, or we can say that it is also like a buffer, right? Now so in the AND gate we have discussed till now, we have discussed 3 things. First is the symbol, second one is the truth table. In the truth table we know that whenever the N input is low, the output will be high irrespective of the other terminal is called what? It's called AND gate. The third one is the enable disabled condition. So the AND gate is nothing, it is just a control 0 disabled or control 1 enabled, right? Now again we are moving on the commutative law. What do you mean by commutative law? In the commutative law, we can say that if we are changing for the commutative law, if I'll change or replace the A with B and B with A, the output will change or output will same. Just give me the answer. If we are changing the value of A or we are replacing the value of A with B, the output table will be affected or that will be the same. That will be affected or same. Jaya, Raju is giving the answer same. Right? Just give me the answer, everybody. Piyush is same. Very good. Santosh, bahut badhiya Santosh, right? So the same. Very good. Very good. So if we are changing the value, interchanging the value of A and B, the output will be unaffected. That's why it follow what? It will follow the commutative law. So in the commutative law, always remember, if there will be the A and B and output is A dot B, if we are changing the input terminal or we are replacing the B with A, and output will be what? B dot A. If the table of these two circuits will be unaffected, then we can say that any circuit will follow the commutative law. And one thing remember, अभी तक आप जितने भी चीजें पढ़ते थे, अभी तक आपने जितनी भी चीजें पढ़ी है, क्या क्या पढ़ी है मेरे दोस्तों बताओ? अभी तक आपने जो पढ़ा क्या आपने अभी तक जो पढ़ा है, that is called what? जितने भी लॉजिक की मैं बात करूंगा, every logic, AND gate, OR gate, NAND gate, NOR gate, XOR gate, XNOR gate, every logic will follow commutative law. दुनिया का हर एक लॉजिक क्या फॉलो करेगा? दैट विल फॉलो द कम्यूटेटिव लॉ, राइट? कम्यूटेटिव लॉ. नाउ वी आर गोइंग ऑन द नेक्स्ट, दैट इज कॉल्ड एसोसिएटिव लॉ. हाउ वी कैन कैलकुलेट द एसोसिएटिव लॉ? जस्ट टेक द एग्जांपल. आई एम जस्ट टेकिंग द एग्जांपल फॉर द एसोसिएटिव लॉ, राइट? फर्स्ट टेक द 3 input लॉजिक. 3 input means A dot B and C. The output will be nothing, it is just A dot B dot C, right? Now we are forming this thing by 2 logic A and B, and output this is connected to the other AND gate, that is called C. Now it is A dot B, the output is A dot B dot C. If both the logic is same, then we can say that the circuit will works as a what? The circuit will be works as what? Or circuit or that logic follow the associative law. So हमेशा एक चीज ध्यान रखिएगा मेरे दोस्तों, every logic will follow what? Commutative law, but yes there will be the some logic just like a NAND gate or NOR gate. हमेशा याद रखो अपने दिमाग में, बाद में आएगा, बाद में डिस्कशन करेंगे, याद रखिएगा सर। थोड़ी सी चीज का ध्यान रखिएगा, थोड़ी सी चीज क्या सर, हर एक लॉजिक जो भी आपसे पूछा जाए, एवरी लॉजिक विल फॉलो एसोसिएटिव लॉ एक्सेप्ट two logic. The one is the NAND gate, another one is the OR gate. So anybody is asking, OR gate follow the associative law? Yes. Right? XOR gate follow associative law? Yes. Yet every logic will follow associative law except only two logic, that is called NAND gate or NOR gate. Now we are moving on the next. We are moving on the next. So my dear friend, if it is a basically nothing, it is just a what? Right now, if we are discussing about what, I am taking a 3 input AND gate, right? मान लीजिए मैंने आपको एक चीज बोला कि just give me the, just take a AND gate or just buy the AND gate for me. I have given 20 rupees to you. I have given the 20 rupees to you, and I have say I asked just give me, just buy a AND gate for me. You went to the what? You went to the shopkeeper and ask about AND gate. They shows you 2 AND gate, right? First that is this one. First that is this one. You are asking, sir, how much for this? They are saying this is for 20 rupees. Just take the example. They are saying this is for the 20 rupees. Now आपने उसको बोला कि भैया और बताओ, जैसा कि आदत है हमारी, right? भैया और बताओ, और जैसे आपने बोला और बताओ, उसने एक और लाके रख दिया, this NAND gate, AND gate. Now आपने पूछा कि sir how much for this? They are saying only 10 rupees. अब आपने सोचा मजा ही आ गया, है 2 इनपुट 20 रुपए, 3 इनपुट का और सस्ता कैसे हो गया, राइट? दैट इज अ वेरी वेरी थिंग आपके दिमाग में आया। आपने सोचा सर को क्या पता, यही खरीद के ले आते हैं, सर को तो वैसे भी नहीं पता चलता, तो आपने ये खरीद के लेके आ गए मेरे पास। और जब आप मेरे पास खरीद के लेके आ गए, आई एम वेरी मच कंफ्यूज्ड बिकॉज you gave me this AND gate which having the 3 input terminal, but I have only 2 input to connect in this. So that is a very disadvantage thing for me, right? Now आपने जो गलती किया है, how we can dissolve that problem, how we can utilize the 3 input terminal as a 2 input device. So I'm asking, sir Veda sir, this question was asked in ISRO. Okay, for electrical Veda, right now अब मैं डिस्कशन कर रहा हूं, that is the important thing, right? Make a note. Now अब मैं कनेक्ट कैसे कर सकता हूं? इफ वी आर यूजिंग A and B and we are shorting this terminal as a like this, right? हमने इसको ऐसे शॉर्ट कर दिया. If we are shorting like this, then it is also B. So here is A, B, B, and B dot B equal to what? C? Huh? B dot B equal to what? C or A or B? Sir, of course, the B dot B is nothing, it is just a B. So the answer will be again A and B. Sir, of course, by the 3 input terminal, I am using what? I am using as it like this, right? Now we are moving on the next. What? I am using A, B, और सर अब इस तीसरे टर्मिनल को क्या करें? तो we are connecting the third terminal by the help of the resistance to this, right? And I am connected as a VCC. It is R. VCC means high voltage, my dear friend. VCC means high voltage. So the answer will be what? The A dot B, and this terminal is called what? High. So it is 1. The value will be again A dot B, right? And this arrangement, any terminal which is connected to the high voltage, any arrangement which is connected to the high voltage is called pull-up arrangement. Pull-up arrangement. Pull-up arrangement. So this device is called what? Pull-up arrangement, right? To connecting any terminal to the high voltage, right? That terminal is called what? That arrangement is called what? Pull-up arrangement. High voltage की वजह से pull-up बना. That is not pull-up due to this, right? This is due to the VCC, right? Now, the third one. The third one is what? If you are asking about what is the third one, is nothing. आपने जब दुकान पे गए, आपको बस एक वर्ड बोलना था in the shop. What? भैया TTL वाला AND gate दे दो. भैया TTL वाला AND gate दे दो. What do you mean by TTL, my dear friend? The TTL means transistor logic. TTL means transistor logic. So sir, what happened in the transistor logic? whenever the logic are designed with the TTL, that is called transistor logic, that floating terminal always already acts as a what? Acts as a high. Do not need to connect that terminal with the battery. That terminal already acts as a what? Act as a high. So we can say that is A, B, and this terminal already acts as a high. So it is 1. The answer will be what? My dear friend, the answer will be A dot B. Right? We have dissolved the problem, right? If you use what? TTL, transistor logic. Again, I'm writing. I'm just again repeating. Whenever the any logic, it is joined with the TTL, transistor logic, then that floating terminal always acts as a high. Do not need to connect that terminal with the high voltage, right? So it is a dot B. Now just give me the answer. There will be the 3 arrangement. 1, 2, 3. 3, 1, 2, 3. Which one is the technically good? Just give me the answer. Right? Yes, Nanda will design by the not only on the example, will design by the PMOS also. So don't worry. Connected रहिए, जुड़े रहिए और like करते रहिए. Right? Right now, which one is the correct one? Everybody is giving the answer. Jaya is giving the 3. Devarshi Vidya is giving the answer TTL. Shirap TTL. Pooja is giving the answer first. Sunil is giving the answer first. Ravinder Payal is giving the answer 2. Piyush is giving the answer 2. Sanawaz is giving the answer 3. So technically 2. Yes, Nanda, very good. Sanawaz is giving the answer 3. And Anthony Stark is giving the answer TTL. Prima Mool is giving the answer 1. Shubham, very good. Everybody is responding for this. जल्दी और response कर दो. फटाफट जो नहीं कर रहे हैं वो भी करो. जल्दी से. Right? Kanaga bhi. Okay. So the most of the student is giving the answer only either first or second. So first or third, right? Few people are giving the answer 2. So just I'm first explaining the third one. Right? For the third one, just remember one thing. There will be the one terms. We'll discuss that terms later on in the logic family topic. But at that time, I'm using as a what? The first, that is called noise margin. Sir, what do you mean by noise margin? How much noise added to the input? The definition of the noise margin is how much noise added to the input, which will not affect the output. Is called noise margin. Right? Again, I'm saying the noise margin, nothing, it is just how much noise added to the input which will not affect the output is called what? Noise margin. Right? So for a good circuit, noise margin should be high or low? Sir, of course, for a good circuit, the noise margin should be as high as possible, right? Again, I'm repeating this one. If I'm taking AND gate, right? In the AND gate, I know before the 10 volt, I'm applying the 0 volt here, right? Before the 10 volt, the output will be always taken, that is considered as a 0. And after the 10 volt, it is considered as a 1. After the 10 volt, it is considered as a what? It is considered as a 1. Right? Now, if then for the noise margin, just give me the answer. If the input is 0, I am connecting, and below the 10 volt will consider as a 0, and above the 10 volt will consider as a 1. Right? Now, if the 0 volt is connected, the output obvious, that is the 0. It is considered as a 0. Right? That is a one terminal device I am forming. Now, how many noise we can make or we can add at the input which will not affect the output? So of course, there will be the limit of the 10 volt. So the noise margin, for the noise margin, if this condition is what? If this condition is 10 volt. The noise margin for this condition is nothing, my dear friend. This is 10 volt, right? Syrup, I'll explain you, don't worry. The noise margin for this circuit is nothing, it is just a what? 10 volt. Now just give me the one answer. If noise आया, उड़ता noise आया, and there will be the lots of noise coming on this terminal, lots of noise coming in this terminal, and the noise make this voltage 2 volt. This noise make this voltage 2 volt. Again, the output will be 0. But just give me the answer. Now, how much noise we can add in the input so that the output will be unaffected? Can you give me the answer? Can you give me the answer? How much noise or how much voltage we can add on the input which will not affect the output? Just give me the answer, everybody. Sir, in this condition, of course, at 8. Sanawaj, very good. So, sir, in this time, the noise margin is nothing. In this case, the noise margin is nothing. In this case, the noise margin is 8 volt. In this case, the noise margin is 8 volt, right? That is a very easy thing. That is a very easy thing, right? Everybody is giving. Pooja, Piyush, Tejashri, Anupama, everybody is giving. Shubham, Shubh Lakshmi. How can you say that the 7? 7 is the wrong, dear. Yes. Syrup, your answer is correct, right? Syrup, your answer is correct. 8, right now. It means, can we make a statement like this? We can make a statement like this. Whenever noise is added to the input, then the noise margin of the system will increase or decrease. Just give me the answer. Whenever the noise is added to the input, the noise margin of the system will increase or decrease. Sir, of course, whenever the noise is added to the input, the noise margin of the circuit will reduce. Noise margin of the circuit will what? Reduce. Yes, Pooja, correct. Decrease. Number 1, correct. So we know that whenever the noise is added to the input, the noise margin of the system will decrease. And we know that a system, or for the good circuit or good system, a system should have noise margin as high as possible, so that the lots of noise also does not affect the output, right? So for the good circuit, noise margin should be as high as possible. But whenever the noise is added to the input terminal, it will affect the noise margin. The noise margin will decrease, and so that we can say that it is a disadvantage, right? So that we can say that it is a disadvantage. Now just give me the answer for this. जब भी कभी हाई टर्मिनल, दिस वोल्टेज, दिस टर्मिनल इज नथिंग, इट इज जस्ट अ फ्लोटिंग. दिस टर्मिनल इज नथिंग, इट इज जस्ट अ व्हाट? इट इज अ फ्लोटिंग टर्मिनल. एंड नाउ इफ इट इज अ फ्लोटिंग टर्मिनल, then in the floating terminal there will be the high voltage. In the floating terminal there will be high voltage. If in the floating terminal and there will be the high voltage, then that terminal also act as an antenna. Antenna is nothing, it is just a wire with high potential. So this antenna terminal also act as an antenna. और एंटीना का नेचर क्या होता है मेरे दोस्तों? एंटीना का नेचर होता है सिग्नल को कैच करना. सिग्नल तो दे ही नहीं रहे, तो कैच किसको करेगा? कैच करेगा नॉइस को. ये कैच करेगा किसको? नॉइस को. इट विल कैच द नॉइस because we are not providing the input. And if we'll add the noise to the input, then noise margin of this condition will increase or decrease. So obvious, the noise margin of this system will reduce. And it is a disadvantage or advantage? Of course, it is a disadvantage. Right? Again, Ravinder, floating terminal acts as antenna. Yes, floating terminal with a high voltage. Floating terminal with a high voltage always acts as antenna, right? Could you explain one more? Yugandhar, just class खत्म होने के बाद उस सेशन को एक बार फिर से देखिएगा. और अगर आपको कोई डाउट आया, if you have any doubt after the session, just listen that thing carefully again. And if you have any doubt again, कल की क्लास में पूछिएगा, I'll explain it, right? So Yugandhar, don't worry about that. In this case, we can say that the noise margin will reduce, and if the noise margin reduce, it is a disadvantage. So this condition not good condition, right? So जिसने 3 बोला था उन सबका हो गया है गलत, right? So इस सबका हो गया गलत. Now there will be the 2 option, 1 and 2. अब मैं अगेन आप लोगों से रिपीट कर रहा हूं, 1 और 2 में से सबसे अच्छा कौन सा बताइए? Which one is the good? Technically that which one is the good, right? Pranav Gupta, can you explain again? Okay, lots of people having the doubt, so I'm explaining again. Just remember one thing, Senwaj, sorry, not Senwaj, and then Pranav, just remember one thing. There will be the 2 thing, right? For a good circuit, noise margin should be as high as possible. That is the condition. For a good circuit, noise margin should be as high as possible. That is the condition, right? Now, just remember one thing more, right? Remember more. Whenever the noise is added, then the noise margin of the system will reduce, and that is the disadvantage. Now for this circuit, TTL logic, this terminal is floating and it is also acts as a high. So in the floating terminal there will be the high voltage, then it is nothing, it is just an antenna. And nature is the antenna is nothing, it is just it catch the signal. If we are not giving a signal, then it will catch the what? Noise. So the noise will be added to the input, or whenever the noise will be added to the input, the noise margin will be the system will reduce. So the noise margin of the system will reduce, right? Right? Now everybody is giving the answer 2, 2, 2, and Yuvandan Joshi is giving the answer 1. Santosh Lawan. Okay, there will be the again tie between the app and the YouTube. There will be one or two, but lots of people are giving the answer too. Okay, just remember one thing. जो दो बोल रहे हैं मैं उनको भी समझा दूं. अगर आप दो बोल रहे हैं तो just listen carefully. Sir, how much of the cost of this? Rupees 10, right? 10 rupees. The battery again 10 rupees, right? 25 paisa register. So the cost will be what? 20 rupees 25 paisa. चलो ये तो आप कॉलेज से भी उठा के ले आओगे. 20 rupees will be the cost. So the cost will increase. So the cost will increase. So it is also, that is not a good thing. ये भी अच्छा तरीका नहीं. It is also a good, not a good thing, right? Because it is a costly. Now for the first one, जो भी कोई first one की साथ दे रहा है, just remember one thing, for the first one is also wrong. The first one is also wrong. Why, my dear friends, the first one is wrong? Because there will be one term that is called fan out, right? I'm just explaining the value of fan out, but yes, don't worry, we'll discuss the fan out, every parameter in the logic family, right? I'm just using the word here, right? For noise fan out, right? What is fan out? Fan out. How many logic are driven by a logic? How many logic are driven by logic is called fan out. How many logic are driven? How many logic are driven by a logic? How many logic are driven by a logic is called fan out. How many logic are driven by a logic is called what? Is called fan out. इसी को मेरे दोस्तों, इसी को क्या बोलते हैं? Fan out बोलते हैं. And for a good circuit, fan out should be as high as possible, right? एक लॉजिक कितने लॉजिक को ड्राइव कर पा रहा है, यही है फैन आउट. सपोज आई एम ए लॉजिक एंड in front of me there will be the 100 logic. In front of me there will be 100 logic. If I am providing the current to the 100 that particular logic, then my fan out is what? 100. If again, second example, if I am a logic and in front of me if there will be the 100 logic and I am providing the current only to the 50 logic, then my fan out is what? My fan out is 50. So for the good circuit, fan out should be as high as possible, right? As high as possible. Now look at this one. If you'll use like this in the short, then मैं ये बोल रहा हूँ, I'm just not using either the KVL and KCL, क्योंकि मुझे पता है कि कंजर्वेशन होता है. But I'm just saying this for remembering you, right? सिर्फ याद रखने के लिए आपको मैं बता रहा हूँ. For the first, if you will provide A and B, there will be the tree, right? And there will be the two terminal device, right? That is A and B, right? There will be the A and B. Now remember one thing, there should be the A and B, two things, and the output there will be the Y, right? Now my dear friend, just give me the answer. If दो input है, then there will be the internal hardware. I'm not giving you any hardware about this. After some time we'll zoom it, right? So if I'm providing A and B here 5 ampere and here also 5 ampere, so there will be that what, and the output there should be the 10 ampere. But I'm saying that illogical thing I'm going to explain you. If there will be the internal hardware and every logic will used 1 ampere as a processing. So there will be the two type, right? दो टर्मिनल है तो अंदर दो तरीके के लॉजिक होंगे and every logic will use what? 1 ampere as a internal processing, for the internal processing. So in the output there will be not a 10 volt, 10 ampere, there will be what? There will be the 8 ampere, right? There will be 8 ampere. Delay propagation भी बता दो सर. पीयूष बिल्कुल दोस्त, delay propagation भी बताऊंगा, टेंशन मत लीजिए. Right now there will be the 3 terminal. So in this case there will be the more complex hardware. There will be more complex hardware. There will be the 3 hardware, we can say that. And each will use 1 ampere as a processing. Again, I'm using 5 ampere and 5 ampere. So in the output, there will be the 3 things to take 1 ampere. So 3 ampere will be taken by the logic. In the output, there will be this 7 ampere. So which logic drive more logic? A logic will drive the more logic which having the more current in the output. And of course, my dear friend, this logic having the more current as compared to this. Again, मैं बता दूं, we are not explaining it what. मैं उस चीज को explain करने की कोशिश नहीं कर रहा हूं कि sir, input current is always equal to output current. I know that. I am giving you this explanation only for the memorizing the things, right? So by this connection the value of the current will decrease, or we can say that the value of the current will decrease, so that it will not drive the more logic gate as compared to this, right? So the fan out in this connection, the fan out should be what? Fan out is decreasing. And if the fan out is decreasing, it means this connection is also not good, because the fan out will reduce. In this connection the fan out reduce. So all the concept is basically the wrong. कोई भी सही नहीं है मेरे दोस्तों, सब क्या है? गलत है। सही तो वही है कि अगर दो इनपुट है तो दो ही लाओ, दो इनपुट है तो दो का ही लाओ, तीन इनपुट टर्मिनल है तब तीन अगर इनपुट है तो तीन वाला लाओ. Otherwise, if you have a 2 input, then just use 2 input device. If you have a 3 input, then use 3 input device. That is a good thing. But yes, if in the technically, if you are very much of rich person, if you are very rich person, then we can say that if the financial is not in the criteria, if the financial is not basically the criteria, then in these three things, the best one is 2. Because we are also providing the current separately, even this terminal is not floating. That's why these noise margin and fan out problem will not occur in the second one. So the second is the basically good one. Second अच्छा होना चाहिए. Sir, these concepts are little complicated. No, Nanda, this concept is not that much complicated. Just remember this one. If there is a 2 terminal device, if you have only 2 input and 3 terminal device, then we have to connect it we have to connect it as this one. That is called pull-up arrangement. Because in this arrangement, the noise margin will reduce. In this arrangement, the noise margin will reduce. In this arrangement, the fan out will reduce. Right? And for the good circuit, fan out should be as high as possible. Right? Fan out should be as high as possible. And for a good circuit, the noise margin should be always high. So just remember one thing. What? 2 points. Pull-up arrangement is good. Second point, whenever the logic are designed with the TTL, the floating terminal always acts as a what? High or low? Just give me the answer. Whenever the logic are designed with the TTL, the floating terminal will be always act as a high or low? Just give me the answer, my dear friend. Of course, it is what? High. Right? Gate. Sir, if we use 2 terminal of 3 input, 2 terminal of 3 input, sir, how it possible? That connection is not possible, right? पूरा पुल डाउन समझा दीजिए सर. हरप्रीत डेफिनेटली पुल डाउन आगे आएगा दोस्तों, पुल डाउन आगे आएगा. नाउ वी आर मूविंग ऑन द नेक्स्ट. राइट, सर्किट डायग्राम की बात कर रहा हूं. नाउ फॉर द सर्किट डायग्राम, जस्ट रिमेंबर वन थिंग. इफ इट इज A, it is a B, right? This diode is known as DA, this diode is known as DB, right? So the name of the diode is DA and DB, A terminal, B terminal. Now in the diode we know that in the diode, that is the circuit diagram, right? So it is basically the AND gate. If you will zoom that AND gate, then the logic will be looking like, or circuit will be looking like this, right? Now in the diode there will be the 2 condition. In the diode there will be the 2 condition. One is the A, another output is A, or we can say that this terminal is called this is basically, my dear friend, diode. In the diode, this terminal is called P type, right? P terminal, and this terminal is called N terminal, right? The voltage applied on this terminal is called VP, and voltage applied in this terminal is called VN. And if VP is greater than VN, then diode is called forward bias. When VP is greater than VN, then we can say that the diode is nothing, it is just a forward bias. Yugandhar, how long the classes are there today? The classes will be, Yugandhar, I think there will be 10:50. Oh my God, 11 बज गए हैं. Within the 5 minutes I'll finish that class, because that class is only for 1 hour class, right? धीरे धीरे इसको हम थोड़ा बढ़ाएंगे भी, but at this time we can say that it is only 1 year class, 1 hour class, right? So VP should be greater than VN. Then the diode is a forward bias, or forward bias means what? Short circuit. Now if VP is, what do you mean by short circuit? It is a short circuit. It is a short circuit, right? Now if VP is less than VN, if VP is less than VN, then diode is what? Reverse bias. And reverse bias means what? Open circuit. Sir, what do you mean by open circuit? हटा दो इसको. This is the open circuit, right? Just remove that diode, right? Now we can say that, my dear friend, we can say that I'm just making the table. It is the input A, it is the B, it is the DA, it is the DB, and it is output Y. A, B, DA, DB, and Y. 0 0 0 1 1 0 1 1, right? So if 0 0 is applied, the diode will be what? If we are applying the 0 at this point, 0 is this point. So this is the N terminal. My dear friend, it is the N terminal, and the N terminal there will be the 0, and the P terminal there will be the VCC, that is the high voltage. So DA and DB both are in forward bias. So these things are both in what? Forward bias. These things are for both in what? Forward bias, right? कैसे निकल गए पता ही नहीं चला, सिर्फ यस सिर्फ, और डेफिनेटली मुझे भी नहीं पता चला कैसे निकल गया, राइट? नाउ व्हेन बोथ आर इन द फॉरवर्ड बायस, देन फॉरवर्ड बायस मींस ओपन और शॉर्ट सर्किट, और ओपन सर्किट शॉर्ट सर्किट, ओपन सर्किट, सर ऑफ कोर्स इट इज अ व्हाट? शॉर्ट सर्किट. सो इफ यू शॉर्ट सर्किट द आउटपुट विल बी व्हाट? डिस्के 0. So the output will be nothing, it is just a 0. Now if you will provide what? Here we will provide 0 and here it is a 1. So if we will provide 0 here and it is a 1, then we can say that in the P and the N type, N side, there will be high voltage as compared to P, because it is a short, so there will be the 0. So if there will be the 0, so in this diode, in the P terminal, in the N terminal, there will be the high voltage, and P terminal, there will be 0 voltage, low voltage. So we can say that this diode is in what? Reverse bias. So it is a forward bias, it is a reverse bias. If it is a reverse bias, then we can open this. Then again the output will be what? 0. Right? Now for 1, it is reverse bias, 0 means forward bias. Again current will flow from this side. If it is a 0, it is 1. Like this. So the output will be what? Again 0. Now for 1, both in the case there will be 1 1. So the reverse bias. If both having the reverse bias, just remove it, right? If you will remove it, then the output will be what? VCC. So VCC means what? 1. Sir, it is nothing, it is just a what? So it is nothing, my dear friend. It is a AND gate. Right? So it is AND gate, right? Yes, my dear friend. So it is a circuit diagram of AND gate. We will discuss the circuit diagram of AND gate after some time by the transistor also. ट्रांजिस्टर से भी बनाएंगे, NMOS से भी बनाएंगे, PMOS, अरे सबका बदला लेगा तेरा फैजल, सब बनाएंगे बेटा, right? Now that is basically OR gate. So we'll discuss the OR gate in the next class, right? We'll discuss the OR gate in the next class, right? So don't worry about that. In the next class we'll do with the lots of example, lots of thing, right? So don't worry till that. जुड़े रहिए, और जिसने लाइक नहीं किया ना सेशन को, वो फिर से लाइक करिएगा, शेयर करिएगा, और थोड़ा सा टाइम निकाल के वीडियो पर कमेंट भी कर दीजिएगा, right? Just comment on it, right? Triggering our level yes, Bhanve, what is the difference between the edge triggered and the level triggered? We'll discuss that in Bhanve. Don't worry, आगे मत बढ़ो दोस्त, सिर्फ जुड़े रहो. Will definitely clear every doubt which comes in your mind. Everything which comes in your mind definitely will clear it, right? And yes, once again my dear friend, आप लोग ट्राई करिएगा किस चीज़ के लिए? लाइक करने के लिए, शेयर करने के लिए, और थोड़ा सा एनर्जी के साथ बने रहेंगे. कल फिर मिलेंगे. We'll definitely will cover that portion in the tomorrow class. We'll cover OR gate as well as NAND gate and NOR gate. 3 gates will be covered in the next class, and NAND gate and NOR gate is called what? NAND gate and NOR gate is called that is universal logic. So we'll discuss why it is called universal logic, and only the NAND or NOR is a universal logic, or there will be some other logic also is called the universal logic. Very important topic we'll discuss in the next class, right? Till that, thank you very much, all the very best, right? जुड़े रहिए, मस्ती करिए, enjoy करिए, right? Thank you my dear friend.